Hello, 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 and welcome to another episode of TGI Kubernetes. Quick soundtrack, can you all hear me? Every time we do these things, I feel like we're always mucking around with the setup and with OBS. But welcome to TGI Kubernetes, and I am Joe Beda, your host. I'm doing it this week, and I'm likely to do it next week also, I think. And TGI Kubernetes is a weekly live stream that either I do it or Chris Nova does it, where we try and explore, parts of the Kubernetes ecosystem, play with projects, learn stuff together. Oftentimes, I'm exploring technology that I don't know all that well, and so we're really finding out about it together. I'm Joe Beda. I'm a principal engineer at VMware. Was the co-founder of Heptio. That's where we started this stuff. And thanks for joining us. We also record it, so this is episode 71. You can go and watch all the old versions if you like. Well, I always like to start out by saying hello to all the folks that are joining us from everywhere around the world, especially. When I first set this thing up, I didn't realize that, time zones, right? So like Friday afternoon here means that it's Friday night or even Saturday morning in other parts of the world oftentimes. So for everybody joining us, regardless of where you're at, welcome. I just want to start going down. I like reading off names. Martin from the Netherlands, Rory from Lochgoilhead in the Scottish Highlands, Bosbank from Lagos, Joe from Atlanta, Sandeep from Poland, Ola from Denmark, Torin, who is the originator, the author, the founder of OPA, I believe. I got to get the right title for him. But thanks for joining us, Torin. He's going to be helping make sure that we don't get too far off the rails. Duffy, who's one of the VMware, what we call him, CATs, Kubernetes architect from the Kubernetes architect team. And he's also done episodes of TGI Kubernetes in the past too. Petri from Prague, Suresh from Hamburg, Ash Lamati, good to see you, sir. Joy, Mike Merrill from New Jersey, Joe from London, Thago from Brazil, Ivan from Colombia. Oh man, it's just crazy. I had no idea when we started this that I'd be that I'd be doing this. All right, so let's see. Eliciano from Cincinnati, Brian from Riverside, Southern California. Yeah, I went to school in Claremont at Harvey Mudd, just down the way from Riverside, Inland Empire. My wife is from San Bernardino. Frank from Virginia, Jan from Palo Alto, Craig from Boston. Oh, man. So good seeing you all. Thank you so much for joining us. What we're going to be covering today is the Open Policy Agent. So this is a project that really makes it easy to start writing custom policy rules that you can control what you or other people can do with your Kubernetes cluster. But before we go ahead and start driving into that, one of the things we like to do is actually just do a little bit of a review of what happened over the week. Now, everything, like all the links and stuff that I'm going to be clicking through, these things are in a HackMD that if we want to crowdsource some notes, if you guys want to put some stuff in there, that would be great. The link is in the comments. After the episode, I'm going to take these and we're going to check these into a GitHub repo so that they get archived next to the episode, and we'll link to that from the YouTube comments. So let me switch to my screen, and here we go. I will make this a little bit bigger. Okay, so first the reference. So OPA stands for Open Policy Agent, but if you're a fan of The Expanse, which is this series of books and TV show, it also is the Outer Planets Alliance. So that is my obscure reference in the image here. There we go. All right, so let's see, stuff that we want to go through. So I just like great articles that we've seen. So Vladimir here wrote a great article talking about using Go modules with Client Go. Go modules are the new dependency tracking system that Go is moving towards. It's been a bit of a bumpy ride, but it's great to see Client Go, which is the sort of official client for talking to the Kubernetes API, just recently switched to actually using Go modules. So that's pretty exciting. So Vladimir goes through a bunch of the details there. There's a bunch of CVEs that have been that have come up, and I think it's worth looking at these. So the first one is a path traversal bug in Kubernetes CP. And the Twistlocks folks actually have an article here that really, so this was, I believe Ariel was that found it, and then goes into details in terms of what the issue is, how it works. I love seeing these things because this is how we learn not to make more bugs, right? Is by understanding these things, going like, wow, I never would have thought that would have been a security issue. So I always love reading in-depth analysis of security issues like this. One small quibble, though, if there's anybody from Twistlock on the line, this is not the Kubernetes logo. You're trying, I'll give you like, an A for effort here, but this is this has 8 spokes on it. So somebody wasn't paying attention there. All right, so the next one, now I haven't dug into this one, so I don't know exactly what's going on. But there is a CVE around CNI. Okay, so this is, so CNI is a bunch of plugins that you can either use or not use. If you're using what's called the port map plugin, and this is used for host ports with CNI, which are not as well, not super well used these days. Most people will use node ports. Host port is a way to say I want a port on the specific host that this thing lands on. This is one that you should be aware of. So again, I'm not sure a lot of people are using this, but it's definitely something to be aware of. And then the other one, and this CVE came out a little while ago, but there's a great article from the Amazon folks. I think it looks like Samuel Karp wrote this, talking about this RunC escape. And this one is really fascinating because there's a small point in time where a container can rewrite the RunC binary by essentially modifying stuff under /proc. And so little did we know that /proc is not read-only for things like binaries. And so that ended up meaning that you could install your own RunC, which meant that future, or maybe even this one, but future invocations of RunC would be running your code. And so really dangerous RunC container escape. And it's super interesting that this one got found, and great explanation here from Samuel. Let's see. And Duffy's saying that this one, which one are you talking about? The CNI one has been making the 1.14 release tough. And the reason being is that the way we package up CNI doesn't have its own packaging, so it's up to the Kubernetes, at least last I checked. So it ends up getting packaged up in terms of RPMs and apt and deb packages as part of the Kubernetes release process. And so that one ended up being a bit of a pain to make sure that we get updated packages there as soon as possible. Oh, go away, Medium. And then the certified Kubernetes exams. These are always interesting. And here's another article from Christian talking about some of the stuff that he did to actually prep for it, which was really interesting. So that's something else that you should know about. And let's see, what else do we have? Griffin O Logging using Loki. So I think George put this one on here. I haven't seen this. And so it's a logging backend optimized for users running Prometheus and Kubernetes with great log search using Grafana. This looks really interesting. So I think logging and looking at how do we collect logs and how do we move past like, hey, just throw it in an Elasticsearch cluster is something that I'd be really interested in digging into at some point. So I think this looks super interesting. Something that I'd like to learn about. So maybe that's something that we should have this is from the Giant Swarm folks. Oh, go away. I just hovered. But this might be something that it's worth digging into on another episode. I don't know. That might be fun. This is from Griffin O Labs. And so optimized to work with Prometheus and Kubernetes. So super cool. Okay, so that is sort of like around sort of what's been happening this week, some cool pointers. Let's see. So I have Frank from Virginia, Jan from Palo Alto, Craig from Boston, Marco from Milan. Let's see. Chris is Nova's over in the next door. Bismarck from Hoboken, Marco from Serbia. Nice to see you all. Any other things that you all want to cover this week? Any other things that you think I missed? Really interesting news, stuff that's coming out? No? Oh, yes. Bismarck says Open Census and Open Tracing have merged. Let's go ahead and we'll put that in there. Open Tracing, Open Cen. So this is, let's see, do we have a merge? There we go. This is Ben talking about this here. So this is interesting. These are, they were somewhat, things hardly ever always really compete, but somewhat competing efforts around distributed tracing, and with slightly different approaches. And open. So it's great to see these things come together. The only other large part of the open tracing system, which is really kind of a different sort of parallel evolution, is Zipkin. So if you're interested in this stuff, Zipkin is also something that's worth looking at. And I know Adrian, who runs that project, is super passionate about it. Anything else that I should be covering? All right, we will then jump in to talking about OPA and the way that we're going to be looking at using OPA. So let's see, let me close some windows here. So Torin, do you pronounce it OPA or OPA? Are we all having a Greek party, or is it, you pronounce it OPA? All right, well, in any case, so OPA is essentially a rule evaluation engine that helps to sort of take a bunch of input and then make a decision, yes or no, on stuff. And so you can use this for all sorts of different things. OPA, break some glass. Okay, so he says OPA, so that's the way it's going to go. And I thought about using a picture from like Greece, like OPA, right? But then I did the planet instead. It's a Greek party, exactly. So let's see. So let's start with the OPA project page. And I think that does a good job talking about, so policy-based control for cloud-native environments. So it's an engine for evaluating rules. And here's some use cases. So you can use it. Kubernetes admission control is the thing that probably is most relevant to the audience here. But it's also can be used for a bunch of other things. Like you can use it for your own HTTP APIs. You can use it for like, say, a PAM module for like, SSH sudo type of stuff, data filtering. So all sorts of different stuff. And then it uses this language to actually be able to express that policy. And it's a pretty rich language. And there's a packaging system where you can pull stuff in. And so that's what we're going to be looking at. But we're going to be concentrating it in the context of a Kubernetes admission controller. Let's see, FOS 9600 for future TGIK is K3S planned. I mean, kind of. I mean, the truth of the matter is that it's an interesting project, but it's really kind of a fork of Kubernetes. The folks from Rancher had to make some big changes there. They didn't work with the community, and there's really not much of an involvement outside of Rancher with that. So I think it's an interesting project from that point of view, but it's not something that I'm honestly looking to spend a ton of time digging into. I'd rather look at stuff that's really sort of more community focused and open. Yeah, and so if there's something that you want to see me cover, feel free to file an issue in the TGIK repo, for sure. And we can definitely look at it. And so, we don't plan these things as much as we'd like to plan them. So really, it's like at the beginning of the week, we're all like, hey, who's going to do TGIK this week? And then we go and pick a topic based on what's going on. And so one of the reasons why I picked OPA this week is because, and I should have had this in the notes, or at least the page up already, is that congratulations, OPA moved to be a CNCF Incubator project. And so this is really sort of the next stage in terms of different types of projects at the CNCF. Where we start out with sandbox projects, where the bar for projects becoming sandbox projects is relatively low. You have to get a couple of members of the TOC to actually sponsor you in, but there's not a lot of sort of diligence or process around that. But the next level is really where we're like, hey, is this something that has some traction? Are there a bunch of people involved from more than just one company? Is it something that we think, really fits in with the rest of the cloud native technologies? Now, it's important to recognize, and this is a subtle point, is that we really try hard with the CNCF to make sure that we don't anoint something as being the solution, but really something that we think is a high quality, well-run project in this area. And so that's why sometimes you'll see something like, Containerd and Rocket, and now we have Cryo all moving into the CNCF. And those are all in some ways operating at the same level with some different approaches, different trade-offs. And so this is really sort of a recognition of sort of the traction and the maturity of the project that we're seeing so far. So congratulations to the OPA project for making this leap here. So that's the thing that I think for me triggered like, hey, let's do an episode on this, which is really fun. All right, so and Lamatti's asking about, hey, let's do an episode on admission controllers. This is kind of an episode on admission controllers because, and I think we could go through and maybe do one where we write an admission controller from scratch. All right, and let's see. So can someone click on Fernand's link there and see if that's something that we should take a look at? All right, so this is something that it really is an admission controller. And so the thing that I wanted to do is like as an intro for what an admission controller is, there's this great article from Bonsai Cloud, and this talks about sort of the admission controller and the systems that they're building, but they really do a good job of actually talking about, okay, link is okay, cool. Let's see what Fernando is pointing us at here. Kate's clusters, oh, biffum Popeye. What is this? This is Popeye. What does this do? Well, debugging a port mapping issue on a dead water application is, wouldn't it be cool to have some kind of cluster sanitizer to quickly assess the live Kubernetes resource state of affairs and issue recommendations based on a cluster scan? Oh, this looks really interesting. All right. Can somebody put that in the notes? And we'll, something for folks to take a look at. Looks really cool. All right. Let's see, where were we at? Oh, I'm clean up some stuff here. All right, so here's the, and one of the things that these folks put in this blog post is a great diagram that talks about sort of the life cycle of a request through the API server. Now, we've talked in the past, and I'll pull up that blog post, is, let's see, Kubernetes, Jazz, improv over orchestra. So this is a blog post that I wrote forever ago that talks about sort of the general architecture of Kubernetes. If you're not familiar with it, it's essentially a database with a bunch of policy in front of it, whereas etcd is typically the database. One of the things that the folks at Rancher did with K3S is replace that database with what did they do? It's the embedded database, the embedded SQL engine. That's like brain fart right now. Instead of etcd, but etcd ends up being the database, the API server, and then everything really talks through the API server. So it's the center of the world. And when we zoom into that API server box, what you end up seeing is a pipeline that looks SQLite. That's right. Thanks, Mario. That looks something like this. Where an API comes in through the API HTTP handler. There's authentication and authorization. There's actually more to this. It turns out that authentication happens. You can actually do that via webhook also, where a token gets passed out and you say who it is and what groups they belong to. And then authorization goes through. There's also an audit coming out of this that we can really dig into. That's super interesting too. One of the folks at Heptio/VMware created a dynamic audit hooks so that you can install audit hooks without having to sort of go and muck with the API server, which is kind of flags, which is kind of nice. And then there's authorization. I believe that you can use OPA as an authorization hook also, which gives you better, more data, different data than what you're going to get as an admission controller. But it's also harder to install. So my guess is that most folks are using OPA as an admission controller because it's easier to install. And this is relatively new. Well, new as in like at first there were sort of validating admission controllers, and then we added these mutating admission controllers. But the idea is that there's a set of admission controllers. Some of these are built in, but one of them that you can enable is called a Webhook admission controller, which means that you can now, via a Kubernetes resource, register webhooks, which means that every time a request comes into the API server, it then calls out to your code to actually say, hey, do you want to go through and modify this particular request? And then you can set up a pipeline of these things. And then you go through object schema validation, making sure that you don't have anything that's malformed. And at any point, these things can error out and return a specific error back. And then there's a validating admission controller. And validating means that you don't get to change the resource, but you get to say yes or no. Is this something that we want to allow? And the interesting thing is that the mutating admission controllers, these things have to be done sequentially because the output of one becomes the input to the next. But for the validating admission controllers, you can actually do these things in parallel. And so it can be more efficient. And then finally, that object gets written into etcd. And this is for a mutation. If you're just reading data, then admission controllers don't come into play, which is one of the differences between audit. Audit actually sees who's reading data. Admission controllers just sees the write path. So that's kind of what an admission controller is in general. You want to be careful with admission controllers because they are in the synchronous pipeline for every Kubernetes API mutation. And so that means that they see a lot of data, they process a lot of stuff. If they take a long time, they can actually break or slow down your cluster dramatically. So something to keep in mind as you actually start doing this stuff. All right, so I just want to see, so like, okay, so Aaron says, hi from Brea, California, just finished Kubernetes up and running, a nice overview. The second edition, we're working on it right now. We're trying to add some more chapters to it. Honestly, Brendan is more of a machine than I am, and he's actually been writing more than I have. And Kelsey hasn't been super involved in the second edition. I am doing a chapter on Ingress, and we're going to do RBAC. So I know those are a couple of things that we're definitely adding to the second edition. I just wish we had more time to actually get stuff out there. I think, we still view Kubernetes up and running, though, as mostly a sort of like just getting your feet under you with Kubernetes. I mean, there's a lot of topics, a lot to go into above and beyond just the simple stuff. So we want to keep it at the sort of new user type of level to really get people so that they sort of understand, the basics of the system. And then Mohammed from Morocco, nice to see you. And Beyond Physics, nice to see you too. All right, so that's what an admission controller is. And so you can read the full article here. It goes into more detail of what's going on here. It's interesting. So there were, pre-mutating admission controllers. There were, it never made it out of alpha. There was a similar feature where essentially you could modify resources before they actually got created. I'm trying to remember the name of that feature. But we actually ended up saying, hey, admission controllers are a better path to go down. And so that's the preferred way to do this stuff now. All right, so that is a little bit of a theory on admission controllers. Initializers, that's right, Torin. Yeah, pod precess is something different, and it turns out that pod precess is interesting. It is a mutating admission controller. And I believe the plan is to actually extract it so that it's actually running out of process now, and it's something that actually is built using the extensibility mechanisms. And so I love to see when we can take stuff from being built into Kubernetes to something that actually can be built on the outside, because that means that now anybody can do this. You don't have to actually sort of get approval from people in the Kubernetes project to get that stuff up and running. And it really sort of lets a ton of sort of innovation happen without any gatekeepers. So that's something that's really exciting too. Yeah, but Torin's right. The feature I was thinking about was called initializers. And so this is also a little bit of a cautionary tale around starting to build on top of alpha level features in Kubernetes too early. Not all alpha features make their way forward, and I think initializers are a great example of that. All right, so as we start digging into OPA, what we're going to do is let me increase the typeface here, the font size. Torin sent me some, and they're in the HackMD here, a bunch of pointers on sort of how we can go ahead and get started. And the one that we're going to actually start with is is the admission controller tutorial. So we're going to go through this. We're going to talk through what it means to actually be an admission controller, what all the sort of nuts and bolts we need to do to be able to wire OPA in. And then we'll play with writing some admission controller policies and see what we can do, see if we can do something interesting around it. All right, so the first thing that we say is this thing is actually, this tutorial is based on MiniCube with the MiniCube Ingress enabled. I'm not going to do that. I like to do stuff on something that looks more like a real cluster, just because I think that oftentimes with multiple nodes, with dealing with something running in a cloud, you end up tackling issues that you don't see otherwise. So what I have here is I have a cluster that was built off of the now VMware Quick Start for Kubernetes, which is essentially a CloudFormation based way of bringing up a Kubernetes cluster, single zone, single master. So it's not sort of like expansive and bulletproof, but we're bringing that up in AWS. It's super easy to do, and that's based on kubeadmin under the covers. So I have one of those clusters up. I actually have an extra one in case I need it, because sometimes you break a cluster, and so you want some Julia Child having the other one in the oven type of thing going on. And so I have that set up here, and I can do kube control, get pods, or get nodes, and we'll see this. So we have one control plane node, and then we have 3 worker nodes, and we're doing version 1.13.2. We haven't updated this to 14 yet. But I think I might have, yeah, I've updated my kube control. So my kube control is 1.14, but my server is 1.13.2. And then since this says that we're going to be using some Ingress stuff, what I went and did is I installed Heptio Contour with this one-liner here. I then went and if I do get service, I then have the external ELB for this. And I went through and configured, let's see, TGI.io. I went and configured a couple of records. So we have an alias record here for the ELB, and then I did star.tgik.io here also. So this means that with Ingress, anything at tgik.io will actually find its way to this cluster. I don't have any sample workloads running yet, but so that's using Contour, which we've done an episode on in the past. And so that means that we should be up and running. This is all about setting the context. All right, so the first thing we need to do is what's going to happen is that Kubernetes will make a call out to OPA. Let's see, so Liciano says, if you're interested in use cases, I've used OPA to limit the creation of a service type load balancer only in namespaces with specific annotation. It's a great example, because like if you're going to give this to users, or if you even just want to make sure that you don't make some mistakes yourself, you may want to say, hey, every time we have a type equals load balancer type of service, that's going to cost me money. I want to make sure that I actually am very deliberate about how I create those things and control that. So great example there. All right. Yeah, and so then you can hand this out to developers, and so it's a very flexible way to be able to hand this stuff out to multiple developers. All right, so the API controller, as it calls out to OPA, that's actually an HTTP call that's happening over your network. And one of the things, and this is a lesson that we learned, hard with Kubernetes in general, is that you want all of this stuff to be encrypted. Sometimes you think, I don't really need it to be encrypted, but I guarantee you, even if you don't need it to be encrypted, other people do, and sometimes in the future you are gonna want this stuff to be encrypted and validated. As you start moving to something like Kubernetes, or even if you don't move to Kubernetes, what you'll find is that it's very easy for data centers or VPCs or whatever to become noisy. You're going to have a lot of stuff running. That stuff's going to be talking to other stuff. IP addresses get reused. Things start spamming stuff like accidentally. There's all sorts of things that happen that can really make even a well-controlled network noisier than you'd like it to be. So having TLS with validation is a really important piece of securing this stuff and preventing accidents, to be honest. Now, Right now, as you're doing stuff like installing a mission controller, you have to go through the painful thing of actually generating certificates and putting these things in there. One of the things that I would love to see is for us to have something like Spiffy as a complement to things like OPA, so that Kubernetes can automatically manage certificates on your behalf. And this is not just sort of talking to public certificates like what Cert Manager does when talking to Let's Encrypt. This is both server and client certificates. And if we can get this stuff automated, we can get automatic rotation in there also. So I think one of the things that you'll see is that we're generating a certificate here once. But if I wanted to rotate this certificate, that would be a pretty complicated manual process that might require downtime. Something to think about as you plan for sort of like using something like this in production. But let's just go ahead and we'll actually sort of copy and paste some commands here to get going. So the first, let me make sure I'm in a good directory here. So the first thing I'm going to do is I'm going to actually generate a certificate of authority, and then what you do here is we're generating a certificate. Let's see, this is actually then self-signing it, I believe. So now what we have is we have ca.crt and ca.key. Where key is our private, and then this is our certificate that we created. So that ends up being our certificate authority that we're using here. And then this is one of the things that's a pain in the butt about OpenSSL, is that we need a file here. We'll go ahead and do that. Let's pull this up in VS Code. If we go ahead and look at this, what we're saying is that we're using I don't know what all this stuff means, but like distinguished name is, let's see, basically it's not a CA. We're using for digital signature, key encipherment, and it can be used for both client and server auth. This is all super obscure stuff from like X509 type stuff. And so now what we're going to do is we're going to generate another key for the server. Same type of thing. Yeah, so CFSSL is actually, I think, probably a lot easier to use, to be honest, than OpenSSL for this stuff. But I don't want to go off the rails too far here and start making up my own stuff. But just something, Torrin, I mean, for the examples here, I don't know if that's something that you've considered. Oh, Duffy's saying that you can also limit services of type equals load balancer using object quota. I wasn't aware of that. That's interesting. So Torrin says they've hidden some of this stuff in the Helm chart, but if you're using Helm, oftentimes you're already pretty insecure anyways. It's very difficult to secure Helm without doing some of this stuff. All right, so, okay. So here what we're doing is that we have we're now creating a CSR, which is a certificate signing request, with the common name of this to be opa.opa.svc, which probably means that we're going to be running this in an OPA namespace. Or, yes, I believe that's what it means, based on this server configuration. And then we essentially go through and we're going to now sign the server certificate using the CA that we created. And then finally, yeah, there's the note. The common name value you give must match the name of the OPA service created below. And then we're going to go through and we're going to upload this to our cluster. Now, when we running this, is this running in the right namespace? Let me make sure I know what we're doing here. So this is running the OPA namespace, and it's going to be using the OPA. The deployment's going to be running in that thing also. So I think, Torrin, or did we do it? Oh, here's where we set namespace equals OPA. Okay, so I skipped this step, and so now we have that problem. I'm just going to go through, and I'm going to go through and say, let's see, I skipped this step because I thought this was just mucking with the config. And I'm going to go through and do this. Yeah, and Torrent's saying this is really sort of doing it the hard way. So let's see if I do this. Yeah, I won't muck with that. I hate the kube control config, and I hate that whole system. Okay, so now we have the YAML that we're going to be using here. I'm just going to copy and paste this into admission controller. Yeah. And then we can look at this. And I'll check this stuff all into the TGIK repo after the way. Okay, Duffy's saying that you can use the InCluster CA for this stuff also. And I don't know, can you use the InCluster CA with, will it actually validate common names and stuff? We'll go through it and we'll figure out what's going on. Okay, but basically what we want is we have OPA view where we have an RBAC role here, which is a role binding saying that we're talking about being able to view pretty much everything in the cluster, and because it's a cluster role binding, and so this means that any of the service accounts from the OPA namespace, I believe, is the way that this works. Okay, and Joe's saying that he has an example here that talks about how to use the InCluster CA for these certificates too. All right, so now what we can do is, and now we have the ConfigMap Modifier for update and patch of some config maps. This is a role within just the OPA thing, because OPA apparently now will be modifying config maps. I'll be interested to see that how that happens. And we're doing the same thing where it's all the service accounts in the, I believe, in the OPA namespace. And then we have a service called OPA. It operates only on 4.4.3. And then we have our deployment. And our deployment is actually, we're only running one of these. I'm wondering if you can actually run an array of these things for redundancy, because like if this goes down, essentially your webhooks won't get serviced, and so I believe Kubernetes fails closed in that point. But in any case, what we have here is we have two containers in this pod. The first one is OPA itself, and here you can see where it's actually using the server keys that we're going to mount onto a volume. And it is hosted on 8181, I guess. Yeah, so it's hosted on 8181. And this YAML is not very explicit about the ports. You don't have to be, but it actually makes the stuff more discoverable if you do. We have a read-only mount of the certificates that we have. And then there's another container that we're having here, which is the kube management container, and this essentially translates between Kubernetes admission controllers and the OPA protocol. So this is essentially a translator there. And what this is saying is, and the other thing that this does is it actually, I believe, and correct me if I'm wrong, Torn, is that it actually reads and caches a bunch of stuff from the cluster. And so what we're saying is that we want it to read all the namespaces and all the ingresses. So these are the objects that it'll have fast access to be able to look at as it's making policy decisions. And then here's the secrets that we mapped. And then we have a config map here, which describes what we want to do, saying that by default our response is allowed true. And then I don't know. This is the OPA language, so I'm not quite sure how this all works. But one of the things that you can see is that this is being embedded into a config map. So this is how we press that stuff in there. Yeah, so kube management replicates objects into OPA so you can refer to them in policies. One minor note, the admission webhook talks directly to OPA, not kube management. Okay, that's good to know. Okay, so I see, yeah, here's 4.4.3. So OPA inside this pod is listening on 4.4.3 directly. And then it's also listening locally on 8181, and the admission controller is talking directly to OPA, so OPA knows how to speak Kubernetes admission control. And but then the kube management essentially provides extra context into the whole thing. Yeah, so let's see. So and then Joy saying, I currently using open various use cases like to restrict accidental override an ingress host path from a different user, enforce resource request limits, and then also whitelist Docker container registry. Yeah, cool. Okay, and then the boilerplate down there is actually essentially that's how you speak Kubernetes admission control. Let's see. So okay, that's cool, Joy. So Joy, just for the accidental or overridden ingress host path from a different user, that's why we built the ingress route stuff in Contour, which is allows for some more self-service of stuff and delegation across namespaces that you can actually defer to users. So it's a different way to skin that particular cat. Okay, cool. So let's go through this. All looks totally reasonable. Oh, I want to see like, let's see. So if we do this, I believe what this means is that the deployment, we didn't talk about service account, so the default service account will get both of these role bindings is I think what we're at. So let's go ahead and do kube control apply Jeff admission controller, and just to be safe, I'm going to do namespace OPA. That stuff is going. And we have our one pod created. Yeah, so what Joe is saying here is he's bringing up that one of the features of OPA is that it can actually integrate data from other sources. And so it's not just a static configuration. It really is a way to integrate a whole bunch of stuff. So OPA ends up being a policy language, but you can have, like, correct me if I'm wrong, Torrin, you could have something like a CSV file and a config map of like what users are not, which namespaces are allowed to do what, and then you can import that and then use that inside of OPA. Maybe not a CSV file, but some sort of data file. And so that means that you're not rewriting the policy stuff all the time. Okay, so I think we are up and running. One of the things that, let's see, what are we doing? So we were restricting, OPA's going to make decisions on names. Oh, we haven't installed the admission controller yet. So the next thing we have to do is we have another object here, which we're going to call Webhook config. Touch web. And so this is the thing that's actually going to configure the webhook. And so this is a validating webhook configuration. Now it turns out that webhook, the validating webhooks, it's a clustered global object. So these things are not homed inside of a namespace. All right, so Torrin's saying that we can load arbitrary JSON data, so not CSV, but the moral equivalent, probably better standardized. All right, so this is the OPA validating webhook. What we're saying is that we want to see create an update of everything, and oh, and actually I need to go ahead and do this and paste this in here. And what it's saying is that, like, hey, when I talk to the service, I expect it to be signed by the CA, the TLS. So this is the certificate authority I expect to see coming from that. So, and we got to like base 64 encode this thing. This is all the muckety muck that is unfortunate here. So I'm going to pipe this to PB copy on the Mac, and then I can come up here and I can paste it, and there we go. Okay. And then so this is essentially, this is how we do the webhook. The webhook says I expect to see the TLS and the other things be signed by this, and then I expect it to be in the OPA namespace. I expect it to be the OPA service, and so that's where the OPA stuff comes from. It's the way that we map services in a DNS across namespace. The first OPA that you see there is the name of the service. The second OPA is the name of the namespace, and then there's .srvs service or something. I don't know. It gets abbreviated, but that's what we had here or no, it was on the command line, but here we go. So that's how that stuff shows up. All right, so now cube control apply -f, and I had webhook config. So that thing is now created, and so now what happens is OPA will be in the path for every create and update of every resource across my cluster, which is kind of scary. I'm wondering, does anybody, I mean, maybe folks who've played with admission controllers more than I have, is there a way to remove an admission controller without going through admission controller? So if you have a broken admission controller, is there a way to say, hey, ignore the admission controllers, make this happen regardless? Because that's something that I'd be a little bit scared of. All right, but we are up and running now with OPA. We've done this. And then we can follow along. Let's see what we have here. I'm going to create another. Oh, no, I don't want it to be that small. Even this is probably too small. We can look at the logs here. Let's see, is that? We're not seeing anything yet. Okay, but that'll follow along. But now we can do cube control, create, namespace. And I have to give it, let's see, OPA is cool. All right, so if we create that namespace, I didn't see it come through. What's going on here? Oh, you know what? I have to reset up all my cube config and stuff. There we go. And I think if we do kale, this will actually show us everything that's there. So sent response. So okay, so we're already seeing stuff happen. We're like, whoa, what's going on here? So there's a request path here. We don't really see any details though about the request. Received request, sent response. That's all we got here is oh, I see. And then the request path here. So here we're actually going through data, Kubernetes, kube system. It's a put, request parameters, and then sent response. Okay. So we're not getting a ton of data here. We're looking at kube public. So somebody's, something's going through and looking at this stuff here. But yeah. Admission controllers can't enforce admission of their own config. Okay, so cool. So like at the end of the day, you can always go through and just whack that config if things are really broken. Yeah, one of the things I like to see is that whenever you do something like this, you want to have a big red button. Like, how can I go through and sort of like, if this thing breaks stuff, how do I make it stop? So that's something that I'm always looking for here. All right, so cool. So there's a lot of background, and as you all know, like there's always a lot of stuff going on in the cluster, and so that was sort of the ambient stuff going on in the cluster. Yeah, and you can use labels to restrict the blast radius of admission controllers too, and so that's something that I think is worth looking at. All right, so let's keep going through our tutorial. Now we're going to define a policy here. So this is ingress whitelist.rego. Rego, how do you pronounce that? Okay, and then Ash says that you can change the log level to bug to get more stuff. Okay, so this is called ingress whitelist. I'm going to call it an allow list. Allow. Is this YAML or no? It's going to be Rego. I like to touch the files there, so then I'm not doing this. Okay, and it's and so I installed the VS Code extension for Rego. Rego is how you say it for Rego here. Okay, so I don't know anything about this, but I'm going to see if I can intuit this language that Torin and company created here. But essentially, I assume that let's see. So here's the rule saying I'm going to deny under these conditions. When the request input.request.kind.kind is ingress, when the operation is create, when I'm going to set host equal to. Okay, so it looks like there's a mixing of assignment and assertions here, and so this is and maybe I'm reading this wrong. This is an assertion that's saying like if this and if this and if this. This is an assignment to a temporary thing so that we can actually refer to it later. And so it's a little non-obvious to me. I'd rather see like this be something like a colon equal or something to essentially say this is actually a local variable that I'm using to make the thing easier to read versus this is actually an assertion for this particular rule. So then I'm passing this, and then this ends up being an assertion also, or maybe it's like see this be a double equal, right? Because that actually says, hey, I'm doing a test versus an assignment. Because this looks like it's an assignment, but it's not. I think. Maybe I'm understanding it wrong. And then this is another test that says like I'm going to call these functions down here essentially saying like if it matches if the fully qualified domain name matches any this host against this valid ingress host. Valid ingress host is actually we're looking at a namespace. Okay, Torrin's saying that in early 2018 we added assignment double equals, which we recommend using now. Okay, so I'm not crazy. Recently refreshed the docs to reflect it, but haven't updated openpolicyagent.org yet. All right, cool. Yeah, because I imagine I'm not the first one that had that confusion around assignment and equality here. All right, so it looks like for this particular stanza, things are either going to be something that produces a bool. If it produces a bool, it's a test, and it ends up being an and across all of those tests to be able to actually say, hey, or no, an or across, no, an and. If all of these things match, then you deny the request using this particular message. So it sounds like I can do equal equal here, equal equal. I could do this, and that should go ahead and work. Oh, and I don't have the OPA executable here locally, so it's do I want to install it? Let's see what happens. Oh, that didn't work for some reason. Cannot read property starts with of undefined. So something went wacky there. Can I do Bruce search OPA? We got this? Yeah, brew install OPA. Hopefully this is the right OPA. Otherwise I'm just installing random stuff. All right, so we'll come back to that. Okay, so we matches any. We have stir patterns. I think this is probably sort of saying I want to match across all the arrays. This is coming from the Ingress whitelist has a comma delimited list, and I'm going through and I want to do host across all of these things. And so there's a split. So there's like an array. I need to understand the language a little bit, but it looks like there's a lot of sort of functional elements to this. And then I go through is that now what I'm going to do is I'm going to split this, look for stars, do a bunch of sort of star dot, and actually figure out what's happening here for matches. So there's actually quite a bit that you can do with the language here. Okay. But regardless, what we're saying is that on the particular namespace, we can add an annotation called Ingress Whitelist. And unless something is on the whitelist there, we won't be able to create an ingress with that. So let's go ahead and give that a try. Okay, so now we have, is this? Yeah, look at that. Okay. So brew install is the way to go. Oh, but there's output every time I did this. Merge error. I don't know. Why was it trying to load webhook config.yaml? Does it just load other random stuff from the directory? Okay, weird. Okay. And then data Kubernetes namespaces. This is then actually being injected into OPA from that other sidecar that we had. All right, so let's go through, and we're going to actually put this thing into a config map. And in the OPA sidecar, we'll notice the config map automatically and load the policy. So how does it know that it's an OPA? I mean, does it look for any config maps with .raygo files and actually just load those things in? So that's something that I think is interesting. I think it's also interesting, other ways. I'm wondering, there's got to be ways where you can actually sort of make that be more explicit versus implicit about loading the config maps. Because this is kind of a convention thing, like, hey, any config map that looks like this, I'm going to go ahead and load it. But just like with Ingress, we have the idea of an Ingress class so that you can run multiple Ingresses at the same time. I'm wondering if there's something similar where you can run multiple instances of OPA being used for different things at the same time. But regardless, it looks like it all is automagic right now. CM deployed within the open namespace or with a specific annotation. Okay, config map. Okay. Okay, it's kube management that does it. It's going to load it out. You can further restrict with a label. So you could set up something like the Ingress class stuff here. All right, and then we can exercise the policy. So let's go through, and I'm gonna, let's see, we're gonna have a namespace called QA. I'm just gonna touch QA namespace YAML. Let's go through and do that. And we're gonna go ahead and do that. So Acme Corp and acmecorp.com. These are the things that we expect our QA namespace to do. So cube control apply -f. So this is also interesting here is that we're doing a kube control create with the config map with the allow list. And I think that, having config systems, and I think this might be something that Customize does, but it's something that we're starting to see with that class of systems. It'll automatically be able to essentially, you keep the file, you keep, the config map. The config map refers to the file, and it automatically knows how to merge this stuff together. Okay, so Torin needs to go. Thank you for joining us. I really appreciate it. Tim is here also, is on the chat, and he can help us out if we totally get ourselves stuck. Thank you so much for joining us for the time that you could, Torin. I really appreciate that. All right, I'm going to keep going through this, and we're going to try and do a little bit more. And then we have a production namespace where we'll be able to do everything under Acme Corp. We called it, let's see, touch. Prod namespace.yaml. Similar type of thing. Cube control apply -f. Prod namespace. Cool. And then, all right, so now we're going to actually try this out. So we have one called Ingress OK. Cube control apply, or touch ingress OK.yaml. And we have Ingress bad. Touch ingress bad.yaml. Okay, so here's Ingress OK. And so here we are doing signin.acmecorp into, well, we didn't specify a namespace, but we'll play around with that. Then Ingress bad, we're just trying to do acmecorp.com. Nobody got access to acmecorp.com, so that's Ingress bad. Okay. Sounds good. And the other thing that I'm assuming here, and this is actually something that's interesting too, is that OPA can be run in its command line. So I imagine that you can use this to do things like set up unit tests so that you can test out your policy. Because anytime you get enough code like this, what I'd want to do is actually test it out with a bunch of input and output and make sure that it does what I expect it to do. So I'm assuming that you know, anytime when you start creating languages like that, you really want to look for, okay, what's the testability? Can I actually make sure that I can get a handle on this stuff? And so the fact that there's this OPA command line makes a ton of sense here, and we have things like OPA format and stuff like that, which looks really cool. And Joe's saying for config maps that kube management detects, it will annotate those with the status of whether or not the policy was accepted by OPA, helpful for troubleshooting. Oh, let's check this out. Kube control, OPA get config maps. Let's see, and we had one. Did we actually, we uploaded it, right? Didn't we? Create. Oh, you know what? I think I put it into the wrong. I put it in the wrong namespace. Ah, good thing checking that. There we go. Ingress allow list. And what do we see? Yeah, and so we now have an annotation here saying status is okay. All right, so that's why OPA needs the write update for the write an update for the config map, is so that it can actually go through and put the status. That's pretty cool. And then Ash is saying that OPA does provide a unit test framework. Yeah, you're right, Joe. You're way ahead of me. All right, so we had that accidentally created in the wrong namespace. Okay, cool. So now let's go through and we're going to actually try these things out. If we go ahead and we try and create the OK one in production, boom, we're up and running. Now let's try and do the bad one in QA, which, you know, the QA environment's trying to do. Acme Corp says, so what we get is an error from the server. Invalid ingress host Acme Corp. Error when creating ingress bad admission webhook. And it tells you which admission webhook it denied the request and what the error was. And so this is absolutely critical, because what we want to know is, like, hey, if something's like screwing everything over and like totally breaking my cluster, I want to know which one do I actually go through and look at and dig into. And so now if I go kube control get val. Okay, so this is interesting though, because it's like, this is the name, this is this webhook, but the thing is called OPA validating webhook. So I'm wondering exactly, where does validating webhook.openpolicyagent.org actually come in? Like, how do I relate that to which webhook that is configured? Ah, there's the name. Okay. Okay, so the configuration has a name, but then the webhooks themselves actually have names. You get one configuration with multiple webhooks. Okay, so there's a little sort of extra layer of hierarchy there. All right, so that's the way. If you start seeing a bunch of stuff, you're going to have to go through and actually start digging through all of your validating webhooks to actually see what happens there. Yeah, cool. All right, and then modify the policy and exercise these changes. So OPA allows you to modify policies on the fly without recompiling any of the service that offload policy decisions to. To enforce the second half of the policy from the start of this tutorial, you can load another policy into OPA that prevents ingress objects in different namespaces from sharing the same host name. So this is to make sure that you don't stomp on people across namespaces. Now, just to be aware that if you're using kubelego, this will break that. But Cert Manager now actually does something a little bit different. It doesn't actually try and use ingress cross namespace in a weird way. So let's go. So this one we'll call this ingress conflicts.rego. Same sort of thing. So now what are we saying here? We're saying that input equals ingress create. Now, is there a way, and I don't know if Tim's online, or maybe if you know, Joe, is there a way, because this is just create, I could actually go ahead and update this after the fact and essentially skirt the policy. And actually, let's go ahead and try that, because I'm looking at my allow list here. We're only looking at create. if I do a kube control, let's see, I'm going to have the, okay, I'm going to go copy ingress OK to ingress hack.yaml. And I'm going to have this one be.qa, and that should work. Kube control apply. Leave out the condition that says applies to only create. Okay, yeah, so I think this is just a subtlety here. So I'm going to try this out and see if I can actually make this happen. Ingress hack.yaml. So, okay, that's called ingress, okay, but whatever. Kube control NQA, edit ingress, okay. So now I can go ahead and I can edit this, and we're going to change this now to sign in. This will conflict or lag, not allowed, like pwned. So I can go ahead and do that, close it. Yeah, and so that actually worked. Okay, so that is interesting here. There's a subtlety here, and I think this is why like this stuff is hard. What you're going to want to do is probably if I do the let's see, the allow list here. We have the create, and Tim is saying that I can leave out the condition for create, which means that it applies to anything, which is going to be either update or create. If I go ahead and delete that, and then now I'm going to reapply the kube control apply -f ingress allow list. I'm going to reapply that. Wait. No, not apply. Create config map. Already exists. Kube control. Okay, so this is part of the problem is that like what I can do is I'm going to do this. I'm going to do dry run o YAML to ingress allow list.yaml. What's the? It doesn't like it. Dry run. What is it? Dry? Is it? I thought we had a dry run. Oh, dry dash run. Okay, so now I have ingress allow list.yaml, which embeds this thing here. So that's just a way to go ahead and get that. And now I can do kube control apply -f ingress allow list.yaml. And it's like I now have to say it's mad. How do I force kube control apply to say do it anyway? I always forget this. Allow missing template keys. Dry run experimental field. What? Oh, okay. Sorry. Give me a second here. Force. No. Overwrite true, maybe. Record false. That one had the -n. I didn't have in the create. Okay, so let's actually go through. Sorry. Yeah, namespace OPA. So we got that there. I think overwrite true, it will actually make it work. Yeah, there we go. Okay, so now that updated it. And so now if I go through and if I try and do that same edit, ingress OK to, and it's mad about something. And now I do super pwned. Let's see, this will work. And it says, yeah, we're not going to let you go ahead and do that. Okay. So now if I go ahead and I do this and I do .qa, now I'm good to go. Cool. All right, so did you all get what happened there? Is that there was a bug in the Rego, and this is the type of thing that I think you're going to want to make sure you get with your unit testing framework, is that like pretty much anytime when you write this stuff, you know, we had the create here. You probably don't want to leave this in because for all intents and purposes, create and update, we want those things to be treated the same. So we'll go ahead and we'll get that. And now what we're saying host is all of the, let's see, we're looking at the host in Ingress. We're looking at all of the other namespace and the other ingresses, as long as it's not the same namespace, because they assume that within the same namespace you can use multiple ingresses with the same host. And then we're doing, is this an equal or a colon equal? Ingress.spec.rules.host. So this ingresses dot other namespaces. Okay, so this is an equal, not equal. This is a colon equal, and equal. Okay, because this one ends up being derived from the input, which is, or no, being derived from ingresses, which is actually the data here. This means that this is actually read-only, I assume here. This becomes an equal. The message, I assume, becomes like that, and then we'll go ahead and do that. Okay. Yeah. So I think that's what we got going on here. Yeah, so this is kind of cool. So this is, now I wonder, like, because this is all, again, very functional in terms of the way that we're thinking. We're essentially saying, like, this other namespace, that's undefined. So we're saying any other namespace, but we're actually, so there's very much a sort of an SML type of thing to this, I believe, if I'm remembering my functional languages correctly, where I'm leaving these things unbound, so they could be anything. It's feels a little bit like TypeScript with respect to the way that you can do, type assertions and stuff like that. So what we're saying, as long as there's another namespace and that namespace is not this, then I'm going to go ahead and actually talk about this. And I assume that part of what OPA does is be able to evaluate this stuff efficiently. Because at the end of the day, this could be an n-squared loop, as we have a lot of namespaces, as we have a lot of hosts. And so we're going to actually go ahead and figure out that. So now we're actually looking about all host names mentioned across all ingress rules, across all ingress in the system. So that's actually kind of interesting. Okay. So now let's do a kube control, create, config map. We're going to do, this is called ingress conflict. From this. What did I call it? Conflicts. All right, you all understand what's going on here? So what I'm doing here is I'm creating the config map from the file, but then I'm instead of writing it back to the server, I'm actually saving it to a file with the dry run-o YAML and then a redirect to the YAML file. And so then this lets me do things like kube control apply -f, where I can now update this because if I do a kube control create, I can't update it afterwards. So now I can go ahead and update that. Now I have the conflicts, and now let's figure out what we're actually trying to do. And then now we can have staging. We'll create a namespace that says that staging can do everything. And then we're going to try and reapply ingress OK to staging. Okay. Staging namespace. Okay, so staging and production both have essentially the same permissions, so they have overlapping ingress white spaces. And now I can go through and kube control apply -f staging. That's up and running. And now I can do, let's make sure I get, we'll go through and do this. And now we're actually, okay, so now what we're saying, error from server, invalid ingress host signin.acmecorp.com. It conflicts with production ingress OK. Error when creating, and then OK, denied the request. Cool. Okay, so this is actually really great error then for users. It's a little bit repetitive, but you'll figure out that like, oh, the host is that this thing conflicts with production/ingress OK, which is another resource in the same cluster. That's pretty cool. All right, so I think that definitely gives us a good flavor of what's going on here. So here's to wrap it up. More information about deploying. This looks like different ways to deploy. The one thing that I did want to call out, though, when we were looking at the YAML, and I just, again, if you're going to be using this stuff in production, it's something that you're going to want to dig into, and I assume that there's some good good documentation here, is that right now OPA is not running with any authorization policy. And so this means that anybody who can reach the OPA endpoint can go ahead and like write whatever they want into it. And so there's ways to be able to actually control it so that you can do this stuff. So Duffy's saying that admission controllers can be expensive though. Yeah, I think this is the thing to keep in mind is that when we go back and we think about that diagram where you have Kubernetes being a policy sitting in front of a database, there is there's a lot of traffic that happens. I mean, Kubernetes is a pretty chatty system. And this is just a lot of heartbeats going back and forth, status updates, that type of thing, especially when you're talking about like stuff coming from nodes and such. So one of the things that I would look to do in terms of admission controllers, and OPA is a very generic system, but like a optimization that you could make is that when you actually configure this, right now, the only thing that we're looking at here is create an update, but we're doing it across of everything. We could actually just look at ingress here, and that would actually help to reduce the amount. So Duffy, and the notes are in there, and this is in the, we have this in the HackMD. Duffy pointed me to this, this article, no, that's not it. This one here. This is essentially, how can we go through and understand sort of why, where, and how are we actually spending time in admission controllers? Don't send the old so yeah, there's ways that you can tune sort of the amount of data that you send to be able to reduce the cost of these webhook admission controllers. So you want to scope that stuff down. And again, there's a danger there in that, like, if we're only running one replica of OPA, and so that means that if that replica goes down, it could actually cause a cascading failure across the rest of our cluster. And so there are capabilities in Kubernetes to essentially say, hey, this is a system level resource. I want to kill this thing last if I have to start killing things. But it's definitely something to keep in mind. And you should have, like, from a sort of SRE point of view, you should have a way where you're ready to be able to deal with the fact that thing may be down, and you need to be able to bring yourself back up. Joe says, with the exposed API, you can do these checks in CI/CD in addition to in place of the admission controller. Yeah, it's a good idea, Joe. I think that's another point, is that, depending on whether you're giving people raw access to a cluster or whether you're having everything go through like a GitOps pipeline, there's pros and cons to each of those things. With raw access to a cluster, you can definitely sort of, it feels very dynamic for development type purposes. You may want raw access so that you can really go through and play with stuff and move fast. For like staging and production, you may want to have something that's much more controlled in terms of how you do stuff, where all of your stuff goes through a GitOps pipeline. And then as part of that GitOps, you can actually go through and apply this type of policy. And let's see, and so Joe's saying with the exposed, but I think it's probably, I don't know if it's possible. I'm sure like you can use OPA as a sort of static checker in a CI/CD pipeline because you have the command line, because it's a separate evaluation engine that you can probably run as a one-shot. I imagine, and I'm speculating here, but I imagine, and this may be what Joe's talking about in the comments, I imagine that there's a way to essentially run this thing as part of a CI/CD pipeline against your sort of GitOps workflow. And then Tim's saying that you can run multiple replicas of OPA for admission. So yeah, so like we could probably go back and change that deployment from 1 to 2 or 3 or 4, right? And so then now all of a sudden I'm feeling a lot better about this, right? I'm no longer sort of have my entire cluster actually on this one thing that could disappear. Yeah, so Tim's saying, yeah, you can definitely check files in Git here. All right, so if I had more time, what I would do is I would start exploring this document here, which starts to go into other examples of what we can do with OPA. So here's an example of, validating the image registry that I want here. Another thing is, now OPA won't mutate. It's not a mutating webhook, right? One of the interesting things is as we look at admission controllers, not the dynamic ones, but just admission controllers in general. This is fascinating. So I bet you all didn't know this, is that there's always... all right. So there's this admission controller here called always pull images. And so this modifies every pod to say, I want to change the image pull policy to always pull. And the question is, why would you want to do this? It turns out it's a security thing. If you have some namespaces have access to a container image, but others don't, what you don't want is that it happens to be cached on a node, and so therefore without pulling it, you can actually do it. So this always pull says, hey, I want to do an access check to see if I'm allowed to pull that image before I actually run a container that does it. So this is a type of thing that you could do this with a mutating admission controller and the built-in one like always pull images. Or you could go through and you could do with like OPA, it's a validating one where I lost where I was using, did I stomp on it? Where'd it go? Here we go, the guides. You could use this where you could actually say, you know what, I'm not gonna like mutate it, I'm not gonna add it, but I'm gonna verify that everybody has it, right? So that means that you now put the burden on your users to make sure that they configure things correctly versus actually automatically fixing it up for them. And there's like pros and cons to each of those things. Oh, Tim says you can set up OPA as a mutating webhook too. The policies look a bit different. Describe a JSON patch to apply instead of simple error message. Okay, that's cool. I didn't realize that. Okay, so that's definitely an advanced mode because now you're actually specifying a patch, which probably is a lot trickier to get right. All right, this talks about... Okay, one last thing I want to actually talk about here. Let's see, and this thing is... So what is the admission review? Oh, this is what actually comes in. This is what is passed in to the webhook. Sorry, I was confused. I thought so. Here's unit testing policies. That's awesome. There's a way, like how the dot notation works. Being able to actually just not look at a single request, but actually pull in other data. Super interesting. All right. The one thing that I do want to call out is that, and this is still a little bit of a work in progress type of project, and this is something I really want to play with. Now, this is something that the Microsoft folks started, and then they moved this into the OPA project, is this thing called Gatekeeper. And so one of the things that you'll see here is that we were manually updating the Rego files and applying those. Gatekeeper, I think the idea is to provide a little bit more structure around this, start moving these things from being sort of config maps and talking OPA directly to being able to actually have essentially more opinionated ways of doing this stuff. So Gatekeeper is a mutating validating webhook that gets called to match Kubernetes 8, blah, blah, blah. So yeah, so I want to see, so the project is undergoing heavy restructuring, but I'm interested. I would love to dig into this, but it looks like it's not quite ready yet. But Gatekeeper seems like it's a really interesting sort of more opinionated way of actually configuring this with Kubernetes. Yeah, so now it's a joint project between Microsoft, Google, Red Hat, and Styra. Styra, which is the company that's sponsored OPA. So yeah, so with that, I think we only have about 5 minutes left. Any last questions, everybody, before we go? And I want to thank Tim and Torin for joining us. It's really great to have folks who really know this stuff. Stevra. Okay. I'm probably still mispronouncing it. I'm sorry, Tim. Coming from somebody who started a company named Heptio, choosing names for companies is incredibly hard. Okay, so thank you everybody for joining me. I'm going to sign off now. Thank you, Tim. Thank you, Torin. Joe on the line here. Joe, you don't work, you obviously know a lot about OPA, but I'm assuming that you don't. I as an eyeball. Styra. Yeah, okay. I see. It's hard for me to read so Styra. The CSS that I apply when I have this stuff in for OBS for broadcasting, I'm not sure I like that typeface. Oh, okay, so Joe's a T-Mobile. He's a power user. All right, and so you all know each other already, so I'm the odd man out here. But thank you, everybody, for joining me. Hopefully this is a great sort of like soft intro as we went through the tutorial together, broke some stuff, played with it a little bit. Hopefully I was able to give a little bit more context, at least from my point of view. Obviously, reach out to folks. Let's see, I assume that if we go and, there is you can reach out on Slack to these folks. So there's an Open Policy Agent Slack that you can join if you want to hear more about this. And I'm sure these folks would be happy to help you if you want to dig into OPA more. And again, congratulations to OPA for moving on from Sandbox to an incubation project. That's really, really exciting. And I think now I want to do an episode just on admission controllers where we maybe write a little bit of code. So thank you, everybody, and we will see you next week.